Okay, so you can see in this example here, you've got the graph of binding energy per nucleon, okay, against number of nucleons in the nucleus, and you're asked to describe the process or discuss the process of nuclear fission and fusion in terms of energy and stability. Okay, so what I would say here is the most stable nuclei are the ones with the highest binding energy per nucleon, because if you think about it, the higher the binding energy per nucleon, the more energy you have to put in to remove a single nucleon from the nucleus. So if I want to remove a nucleon from iron 56, I need to use about 8.79 mega electron volts to do that. Whereas if I wanted to remove a nucleon from helium 4, I'd have to use about 7.1 mega electron volts. So the iron 56 is the most stable nucleus because it's got the highest binding energy per nucleon. So you might want to say something like this: the most stable nuclei have the highest binding energy per nucleon. Iron 56 is the most stable nucleus at the peak of the curve, okay, which is there. You then may want to talk about nuclear fusion. So let's talk about nuclear fusion to begin with, okay? So nuclear fusion is the process where two low mass nuclei combine to form a nucleus of greater mass. The product nucleus has a higher binding energy per nucleon, okay, and therefore is more stable than the reactants. You also may want to say that the mass of the product nucleus is less than the mass of, or maybe less than the combined mass of the reactants. This missing mass is converted to energy. There we go. Okay, so that's nuclear fusion. So what we're saying here is things like these two hydrogen nuclei, like hydrogen 2 and hydrogen 3, so deuterium and tritium, may fuse together to produce helium 4. Okay, and that has a higher binding energy per nucleon. Now, we then could talk about nuclear fission. So nuclear fission is the process where a nucleus of high mass splits to produce two nuclei of lower mass. Okay, so something like uranium might split to produce krypton and barium or whatever. Okay, so nuclear fission is the process where a nucleus of high mass splits to produce two nuclei of lower mass. You can say that the product nuclei have a lower binding energy per nucleon, okay, and are therefore more stable than the original nucleus. Okay. Finally, you can say that the mass of the product nuclei, or you can say that the total mass maybe would be better. The total mass of the product nuclei added together is less than the mass of the original nucleus. This missing mass is converted to energy. There we go. Okay, so that's the sort of thing we're looking for in our answer to this type of question.